is a calendar of all the weeks that we have left. This is today. So we finally got guidance on the final exam situation.
Yeah, what's going on?
And basically the instructions are, the grades are the average of the 4 quarters. And if a student is failing when you average those 4 quarters, then we're supposed to give a final exam to those students. And if they pass that exam, then they pass the class. That's
Why did I do anything?
right. But it's going to be noted somehow. It's going to be noted that they actually failed the class, but they're going to get credit for it. It's very strange. I don't really understand. Yeah.
Well, like for all of us, it's because we have to know.
Right. So that's what I wanted to get to. So literally every single person in pre-calc is passing, so we're not going to have a final exam.
Yeah.
I actually thought it might be better if we just like learn for a couple more days just to get a little more stuff done, and then that'll be it.
Yeah. Oh my God.
If anybody objects and would like a final
Watch
exam,
your mouths.
then I'll reconsider.
If anybody objects,
Okay.
shut up.
So here's the plan for the rest of the year.
Okay.
Okay? We're gonna do new stuff. Like this whole time, we're gonna have a quiz this day, a normal Wednesday quiz, and then free the rest of the day, just like a normal Wednesday.
Okay.
New stuff that Thursday. There's no school Friday, Monday, or Tuesday because of Memorial Day. We're not gonna have a free day this day because it's only a 3-day week. We're gonna do new stuff those days. Check my schedule. And these days, we're gonna have a free day this day. And then we're gonna do like normal unit test. So this would be like test review this day. And then a test on unit 13. And then we'll just be totally free the last week.
Yeah.
Cool. Sounds good.
Well, that's the plan. Does anybody have any questions about that plan? So there's not gonna be any kind of cumulative thing at the end. This is it. It's just, this test will just be on the stuff we start today until then.
Okay.
Okay?
So that test is basically on everything that's up there on that side.
Correct.
Okay.
Any questions? Okay, so today we're going to be talking more about derivatives. In particular, it's derivatives of functions. So far, we've been able to calculate the derivatives of functions at a particular point. Like, for example, if I were to tell you f of x equals 3x squared, find f prime of 2 or something like that. That's what we've been able to do right now, right? So I'll go through it just to remind you how that works. You'd say f prime of 2 is the limit as h goes to 0, f of 2 plus h minus f of 2 divided by h, right? That's the formula. So then you would substitute f of 2 plus h for what it actually is, which is this function with the x replaced with 2 plus h. So it would be 3 times 2 plus h squared minus 3 times 2 squared divided by h. Right, this is what the test was on pretty much, the last test. So this is the limit as h goes to 0. If you FOIL this out and distribute the 3 at the same time, I'll try and do both of them at once. You end up with 3 times 4, which is 12, and then 3 times 4h, which is plus 12h, and then 3 times h squared, which is plus 3h squared, minus 12 over h. right? Then the 12s cancel. What do you do next? Yeah, common factor of h. So this would be the limit as h goes to 0 of h times 12 plus 3h divided by h. And then h's will just cancel. And then you can just substitute in h equals 0 and get an answer, and you're done. So the answer here would be 12. Any questions on that? Now, what if, instead of the question saying find f prime of 2, what if the question was find f prime of 2, f prime of negative 3, f prime of 0, and f prime of 7? You have to do this whole thing 4 times, right? Which is ridiculous. So there's a better way. You can actually just find a function that is actually called the derivative of the function, the original function, that enables you to just substitute in 2, then negative 3, then 0, then 7, and get the answer really quickly once you have the derivative of the function. And all that entails is, instead of actually substituting in a number here and here for a, just have it be a, or x, or anything you want, any variable you want. And what will happen then, if you just let this be a variable, like let's say it's x, if you just have this be the variable x, then when you go through this process, you're going to end up with an expression down here that involves x, and then you'll just be able to substitute those x values in for x to get the derivative at those points. So the way that would look here is I could just say f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x divided by h. And then just do the same process we just did. So this would be the limit as h goes to 0. It's a little bit more abstract because there's going to be 2 variables kind of floating around, but it's just algebra either way. This is going to be 3 times x plus h squared minus 3 times x squared divided by h. And the simplification process is the same. I'm going to FOIL and distribute the 3 at the same time. So I'm going to get 3x squared plus 6xh, because it's 3 times xh, 3 times xh, right? Inside and outside terms. And then plus 3h squared minus 3x squared. And just like before, everything should cancel except for things that have an h in them. So you're still going to be able to take out that common factor of h in the next step. So you're going to get the limit as h goes to 0 of h parentheses 6x plus 3h for h. And then the common factor cancels. And now you can still plug in 0 for h and get an answer. The answer is 6x. And this is called the derivative of f of x, 6x. That means if I wanted to find f prime of 2, I could just plug 2 in there and get 12, same answer I got here. If I wanted f prime of negative 3, it's negative 18. Without any additional work, I just plug negative 3 into this expression. If I wanted f prime of 0, it's 0. F prime of 7 is 42. Without doing all that whole process 4 times. I only had to do it once. Does everybody understand that? That's called finding the derivative of the function. Now, let's just talk about vocabulary for a second because it's a little weird. Derivative, is the noun. You find a derivative, you calculate a derivative. But the verb for that is actually differentiate. It's not derived, which if I was in charge, I think it would be derived. But it's differentiate is the verb. It means to find derivatives. If you're finding derivatives, you are differentiating. So it's a little weird. It seems like the verb for derivative should be derived, and it seems like the noun for differentiate should be differential. But those two things actually mean something totally different in math. It's kind of weird. So you got to kind of just understand that this is the way that it's set a long time ago, and we're kind of stuck with it. So sometimes you'll see the word differentiate this function, and it means find the derivative of this function. Okay, that's all it means.
Okay.
Also, different ways it might be written. They might say f of x equals whatever, find f prime of x. They might say that. Or they might just say find d dx of f of x, which means find the derivative of f of x. This symbol right here, d dx, it's all one thing. It's not like a separable fraction. You can't separate it out. This is all one thing. And it just means the derivative of. Okay? So these two ways of saying this are interchangeable. They mean exactly the same thing. This is just a little less cumbersome. You don't have to write as many words. So they use this quite frequently. You just have to recognize. Okay, any questions on that? Okay, so now the good news is we have this way to calculate the derivative of a function that makes it so we don't have to do all that work multiple times. The better news is there's actually a shortcut that makes it so you don't have to do this work at all. Here it is. Okay, this is shortcut. And if you take in physics, you might have actually learned this one.
Yeah, no, we haven't learned anything in a long time.
She's kidding if you're listening to this. This is a shortcut for finding derivatives. And it's called the power rule. And it works for any function that looks like this, a power of a variable, like x cubed, x squared, x to the 1/2, x to the -7. It doesn't matter what the exponent is, this power rule works. Okay, and here it is. The power rule says the derivative of, right, that's what this symbol d dx means. I wrote it up here, right? It means the derivative of x to the n. So n can be any number at all. Derivative of x to the n is n times x to the n minus 1. That's the rule. So n could be any number. N is any number. So, for example, if I had like the derivative of x to the 5th, it would just be 5x to the 4th. The old exponent becomes the coefficient, and then you just subtract 1 from the exponent. Now think about how much work it would be to actually calculate the derivative of x to the 5th. What would you have to do? You'd have to find the limit as x goes to, or as h goes to 0, sorry, the limit as h goes to 0 of x plus h to the 5th minus x to the 5th over h. You'd have to like boil out x plus h times x plus h times x plus h times x plus h times x plus h. And then expand it all out. The x to the 5th would cancel with this x to the 5th, There'd be a common factor of h left in all the other terms. You'd have to factor that out, cancel the common factor, then plug in h equals 0, and out would pop this thing right there. Okay, it would be a ton of work. And you'd probably make mistakes. I know I would. If I was trying to FOIL out x plus e to the 5th power, I would probably make mistakes along the way. There's a lot of places to make mistakes. So this shortcut is really super valuable time-wise. All right? If I had the derivative of x to the 12, it would just be 12x to the 11. That's simple. Nothing to it. And like I said, it works even if the variables, if the exponent is fractional. Like if I had the derivative of radical x, this is really the derivative of x to the half, right? That 1/2 power is the same thing as square root. The rule still works. It's going to be 1/2 x. If you subtract 1 from 1/2, you get negative 1/2. Which, if you wanted to write this without any negative or fractional exponents, that's easy. The negative exponent you get rid of by just moving that term to the denominator. And the fractional, the bottom number tells you the root, right? So this is 1 over 2 radical x. That would be the answer. That's the derivative of radical x. It's 1 over 2 radical x. Or the exponent could be negative to start with. Like if I had the derivative of 1 over x cubed. This is really derivative of x to the negative 3. Right? 1 over x cubed is really x to the negative 3. So the exponent becomes the coefficient. And you subtract 1. What do you get when you subtract 1 from negative 3? Negative 4. So this would simplify, if they wanted you to write it without negative exponents, this would simplify to be negative 3 over x to the 4th. Now there's one other shortcut that makes this even more useful. It's called the constant multiple rule. This is the power rule of this rule. This is called the constant multiple rule. The constant multiple rule says if you have the derivative of a constant, let's just write that as c, times a function, you can basically just ignore the constant and multiply it after you take the derivative of f of x. So I'm going to write that as c times the derivative of f of x. You can ignore the constant until the end. So that's a little abstract looking. So what it actually means in practice is like if I had something like the derivative of 3x squared, like the example that I did at the beginning of the period, this is really just 3 times the derivative of x squared. Well, the derivative of x squared is 2 times x to the 1st power, right? The exponent becomes the coefficient, and you subtract 1 from the exponent. So this is 6x. But if you look up at my work, I actually got 6x.
Yeah.
By doing all this work, I don't have to do all that work now. It's just 6x. So if I had the derivative of 5x to the 3rd power, it would just be 5 times 3x squared, or 15x squared. Now, you don't have to write this step necessarily. Like you might just see the pattern, and you're just going to multiply the coefficient and the exponent to get the new coefficient, and then subtract 1. That's the even shorter cut, right? That's what's really happening. So if I had the derivative of negative 4x to the 7th power, the answer would be negative 28x to the 6th power. You see where all that stuff came from?
Yep.
Now, one other thing that I forgot, didn't really forget, but I just haven't given an example like that yet, is if I have the derivative of 6x or something like that, if I follow this rule, there's an exponent here of 1, right? If I follow this rule, I get 6x to the 0 power, right? That's following the rule. Well, what's x to the 0 power? 1. Anything that's 0 power is 1, so this is really just 6. And that's correct. That's actually the derivative of 6x. Which makes sense logically. Like if you just think about what the graph of 6x looks like, y equals 6x, it looks like a line, right? And the slope of this line is 6. So it makes sense that at any point on the line, the tangent line would also have slope 6. And that's what we're doing. We're calculating the slope of the tangent line. So it makes sense that you get 6. One other little thing is derivative of any constant so a constant is just a number without a variable attached to it, right? The derivative of any constant is, what do you think? It should be. Like, for example, before I finish this sentence, what if I have the derivative of 5 without any x's attached to it? What do you think that should be? It's not 1. It's 0. Because if you just think about what the graph of y equals 5 looks like, y equals 5 is a horizontal line. That's the graph of y equals 5, right? So at any point along that graph, doesn't it make sense that its derivative is 0? It's a flat graph,
Yeah.
right? It's horizontal, which means its derivative is 0. So this would just be 0. So the derivative of any constant is 0. It doesn't matter what that constant is, it's 0. Like it could be the derivative of pi to the 5th power. Don't be confused and say 5 pi to the 4th. That's definitely not it because pi is not x. Pi is a number. So this is really just a number. The answer is 0. Right? The variable is x. So pi to the 5th doesn't have any variables in it. It's a constant. Its derivative is 0. Okay? Any questions about this? So the homework tonight is just called power rule in Delta Math, and it just is practice with this rule. These problems should take you like 10 seconds each. You got to get used to doing it really easily and quickly, and that's all there is to it. You just take the exponent, multiply it by the coefficient, if there is one, and then that's the new coefficient, and then subtract 1 from the exponent. That's the general rule. Okay? Also, at the beginning of the class, I forgot to put the test scores on the board. I'll do that
Okay.
right now.
Thank you. You should be math. I'm the rest, Sarah.
Oh, right. Hello, everybody. Okay. I'm not liking the sudden.
Remember, test corrections are due Monday.
This week, correct?
This is not good. This is
I prefer
before corrections.
this way to the rest.
Oh, my goodness.
You just I was gonna go like, this way pushes me out so much. I know it's just like so good, basically. I don't. Yeah, I love that. Then she does.
Oh, and then the beach, the army.
That show is so good. What happened to that?